Welcome to my YouTube channel. In this video, we are going to look design of shallow foundation with robot structural analysis. So first, that we see the input record or a record input. Geotechnical or soil investigation report, which is having the soil type, water table, safe, allowable bearing pressure, angle of internal friction of soil, recommendation of foundation. Next is foundation loadings. For that foundation layout is required to identify which kind of a foundation to be performed. Either it is a single isolated footing which is holding a one column or combined foundation which is holding two column in a single base slab. Generally, if it is a center to center distance of any two columns are less than or equal to 1.5 meter, it is better to go for combined foundation as there will be a some foundation collision if you are going for single isolated foundation for a center to center distance less than or equal to 1.5 meter. Next under foundation loadings is primary load values. What are the loads are to be applied on the foundation? Horizontal direction X and Y, and in vertical direction upward and downward. Movement about X and Y. So these are the primary loads which should be categorized under various load cases such as sulfate, live load, wind load, seismic, or any other load such as temperature. Standard code to be followed for load combination, material and design. Standard codes, maybe it is a Indian standard or European code or American standard or SNP or Indonesian, Philippines, Algerian or Chinese, Japanese. It's depend upon the national code and the project requirement. Also other input for documentation purpose such as project name, owner, prepared by, checked by. So these are the basic input required to perform a design of a shallow foundation robot structure. Now let me go for a demonstration with the robot structural software. When we open the robot structural analysis software, this is a landing page. For that, need to click new. In the fourth row, first icon, which is showing RC elements design to be clicked. Right side in the top, from the top, the third icon, new foundation to be clicked. So this is in the bottom, you can see the dimensioning of a foundation, the input which is required for the foundation dimension to be provided here. In the top or in the middle, you can see the window showing the foundation dimension in a pictorial format. This is uneditable format here, where we cannot able to edit directly here. Only through this dimensioning parameter in the bottom pane, only we can able to edit the foundation. So next, first we need to give the project properties which is required for the documentation purpose. So here demo on isolated foundation. Similarly, like we need to give all the information, all the required information for the documentation purpose here. Next, we need to fix which standard we are going to provide this design for load combination, material and design. For that, we need to click tool, job preference. Under this material, by default, it is showing some American standard. You need to select Indian standard. Basically, this design first we are doing in Indian standard. I need to worry about steel, aluminum and timber because my foundation is in concrete. So I am selecting this concrete as M25. Next under database for steel we need to select Indian standard. So this one is my standard to be followed for steel. And no need to worry about vehicle load, standard load, building, soils, anchor bolt, reinforcing bars. So this is required to fix for a code. As it is Indian standard, we need to select IS 456. Here it is. And after adding into this list, we need to set the current database by clicking this tab. Next, design code. For design code, we need to select from this list IS 800 for steel. Steel connection, we are not going to do any steel design, leave it that. Even timber also, no need to worry about it. For RC structures, again IS 456. For geotechnical, it is not required at this time. So next is loads. For load code combination, we need to get from IS 800, sorry, IS 875 part 5. So for snow load, again we need to pick up from yes IS 875 part 3. For seismic load, for Indian standard IS 1893. So this software is having only 2002 version. Now the latest version is 2016. Anyhow, so I am save current parameter as default. So this will be saved as a default parameter. We no need to change again and again in case of for new design of a foundation. So I am clicking OK. Member parameters have been defined for code BS. Convert parameters to the code IS8. If not, the default values will be set. Yes. So now we had assigned the standard for our foundation design. Next parameter is we need to provide is calculation option. For that analysis calculation option to be selected, or alternatively the second division of this tab, you can see here calculation option in the right hand side. It's a third icon from the second division of tab. So here the punching shear under general tab, if it is a NR is a resisting punching shear, depends upon its material and other parameters. N is a actual punching shear from the external loads which we are going to provide now. So if this factor, if it is to be considered as 1 or 1.5, that we need to provide. So I am considering here 1.5. Similarly, like this cover to the reinforcement 50 for C1, that is for the base slab. C2 is for a pedestal or column. So I am considering default value which is here. Next is concrete. For concrete grade we need to select. I am selecting M25. Accordingly the strength we need to enter here. So by default it will be coming right way, correct values here. An aggregate size, if you are going for 16 mm or 14 mm, that you can select from this drop down list. The next longitudinal reinforcement to be defined. For that grade to be selected from this drop down list, and accordingly the standard reinforcement diameter to be selected here. So I am limiting my design with 20 mm diameter, so no need to select all the other. I am deselecting all the other diameter from the list. For a transverse, that is distribution rod, the same grade I am adapting, and similar like the diameter also I am deselecting which are not applicable for my design. Additional reinforcement also need to select. This is for other ring rods So likewise, I am fixing my diameter and the grade of steel here, even the grade of concrete also here. So then click OK. Next, you need to provide geotechnical option. Analysis geotechnical option. So what is a factor we need to provide rotation, that is overturning, and for capacity, that is bearing capacity. Bearing capacity we can have it to 1, there is no issues. In case of load combination for wind or seismic loads, which kind of bearing pressure we have to consider, which factor, whether we need to consider the all the full allowable bearing capacity or else some limited, that is a factor to be considered. So here by default it is provided 0.75, let it be 0.75 in our case also. Average settlement, so this parameter we need to provide according to the soil report and the requirement. And here is a contact surface, loss of contact. So even the loss of contact considering for wind or seismic. So I am considering the default value. Only thing I am changing here as 1.5. Earlier it was 1. So then click OK. Next input is we need to provide the soil parameters. Click RC element, soil icon. Alternatively, you can click from right hand side, second set of icon, seventh icon from the top, which is labeling soil definition. N1 is a natural ground level, NA is a pile level, minimum reference level is NF. If your foundation is encountering water table based upon the soil investigation report, we need to select this or else we can untick this. So for that we need to give maximum, which is from the top of the natural ground level, the minimum which is below the ground level. So here we can assume minus. So this value should be in minus as it is going down from the natural ground level. So for our case, we no need to consider this water level for our demonstration purpose. Also, there are various soil parameters which is available in this database. For that, we need to go edit database. We need to check all this, tick all this soil type, or else we can select which are the soil type applicable for our project based upon the soil investigation report. So I am telling that clay is not applicable and poorly soils are not applicable for me. So those are well graded soil I am considering for our calculation purpose. So let me consider only this kind of soil parameters are applicable based upon my soil report. So those are well available here. So I'm selecting some soil data. The color coding also change accordingly. So the input like unit weight of soil, angle of friction, cohesion value, all those information will directly come through the database. So second layer also I can provide here. So likewise I can define the soil parameter based upon my soil investigation report. Click apply. So then close this window. Almost we had provided all the basic information required for the project, entire project. So now we need to provide the input which are exclusively for this foundation design. So for that first parameter we need to provide is load, that is primary load under various categories like dead load, live load, wind, seismic, snow. So all those parameter we need to provide. So let we see. So in the foundation view window, you can see a table showing the foundation loads for RC pump house building. So this is a sample load which we are going to discuss for this demonstration purpose. So here there are in the left hand side you can see there are a list of load, the load ID 1 to 7 stating that dead load DL, live load LL, wind load in X, WX, wind load in Y, WY, seismic load in X is SX, seismic load in Y, SY, snow load SL. So these are the 7 load, primary load which we are going to consider for our demonstration purpose. So let me tell you how to select this loading parameter. First we need to define the primary loads. So for that RC element loads to be clicked here. So here in this window, first one case is all are foundation load only. So the group let it be 1. Later I will explain what is this group mean. So dead load DL I am adding under we can consider as foundation weight, add. So next one is we need to add live load. This is live load short term I am adding. Next one is wind load. Wind load there are two cases, WX and WY adding. Next one is WY. Next the fifth load case is seismic. S X X Y. Finally snow load which is S L. So adding all the load type are added here. Alternatively, you can find out from this icon also here. So now we had provided the type of load which we are having: dead load, live load, wind load, seismic and snow load. Now we have to provide the input like direction and magnitude of the forces which are listed in the table. For that, under RC element load table to be clicked. So I am just moving this table into here. Now we need to enter the values which are shown in the table here into this table which is listed here in the bottom of the tool. So start with the dead load, live load, wind load. We need to enter n value f of x, f of y and m of x and m of y, whereas fx and fy are the horizontal load and n is a vertical load. Mx and My are moment to respective to the direction. Before going to enter the wind load, I need to explain what is a group means. So group is nothing but we are having a four kind of directional load: Wx, Wy, seismic Sx and Sy. These four loads never get combined together. So that is the main reason we need to provide the group value. Here I am considering wind x, Wx as 1, Wy, seismic Sy as 4. So it means if I am providing wind x, Wx as 1, this will combine together with first group dead load, first group live load and first group snow load. So for other three group like 2, 3 and 4, we need to provide the same dead value, dead load, live load and seismic load value. So like this, we need to select here dead load. So for that group 3, for dead load, for group 4. Similar like live load for group 2, 3, live load for group 4. Same wise, snow load for group 1, group 2 to be considered, snow, snow load for group 4. So now we need to enter the values correspondent to the table N, Fx, Fy and Mx. So those are same as like we are considered in first group. So I am going to enter the same value here. Okay, now you can see all the loads are entered here as per the table above. Also the group also segregated based upon the wind X, wind Y, seismic X, seismic Y. So next we can move to dimensioning of a foundation. So in the left hand side you can see in the bottom. So this is a dimension parameter which we need to provide for the foundation sizing. So here A and B you can see in the picture. It is length and width of the base slab. H1 is the thickness of the base slab. Here we can consider 0.4 meter as our thickness. H2 is a height of a pedestal above the base slab. So this we can consider 0.9 meter. H4 is nothing but it is a thickness of lean concrete. We can consider 50 mm as it is. So even if the software is try to do any optimization by decreasing or increasing the sizes, we are selecting this fixed option. It means these sizes should not be changed according to the software optimization. So similarly, we need to provide column sizes, width and length, eccentricity of the column with respect to x and y. We can consider 0 and that also fixed. So now I am applying this. Just you need to press this calculate tab and now you can get a short note that seismic disposition no requirements. So no ductile requirement is found because the seismic force are very less. So now you can see the foundation sizes 1.2 by 1. If I want the square footing means I can go to optimization and select square footing, apply, again recalculate. Now you can see 1.2 by 1.2 as my foundation size. So now the foundation is optimized as 1.2 by 1.2 meter as base slab. So next we need to click this in order to find the results. So you can see the bearing capacity, contact surface, average settlement. So this calculation result you can see here and the various load combination you can see here in the right side. SLS service limit state, ULS ultimate limit state combination, and here in the top view panel if you press this foundation reinforcement tab you can see the 3D view or other view of foundation. You can rotate this to see that. In the bottom you can see the tabular format which is showing the reinforcement information about the spacing and the number of bars to be provided. So you can also get the detailed calculation notes here by pressing the tab foundation note. So now we can move to foundation view itself. In similar way we can calculate the combined foundation also. So for that we need to click the tab here in the bottom This icon is meant for combined foundation. You can see the pictures here also. So the same column size we can consider 0.4, 0.4. So here also no eccentricity and spacing between two columns is 1.5 meter E2. Again, base slab thickness you can assume as 400. Height of pedestal above base slab is 0.9. Apply. Okay. This value should be 0.4. So now the foundation size you can see in this picture. Now again we need to check the load. Here one column we are already entered here, the n value, fx value and f of y, m of x and m of y. So I'm just copy and paste here for the next column also, n2, f of x2, f of y2, m of x2 and m of 2, which are for the second column. We can also change according to our requirement. So now again I am pressing apply, clicking the foundation result. No, before that we need to run the calculation. So now the foundation size is adjusted accordingly, 2.2 by 2.2. So these are the result view, these are the reinforcement view, and the respective reinforcement are tabulated here, and these are the calculation notes for the combined foundation. So next you can see block foundation. For that there is no H2 value, there is no pedestal above base slab. So simply pressing all other parameters are same. So simply pressing apply, it is coming 2.2. The dimension are updated here in the image. Again the calculation we need to press. So now the foundation size base slab is 2.3 by 2.3. Again you can see results, the reinforcement notes. So we can also get the tentative foundation drawing from the result plus the drawings. Here you can see it is a tentative drawing, but here the unit of measurements are in some meter and centimeter. For that we need to update the drawing style. So let me come out from this screen, and under analysis you need to update this drawing parameter. Here you can see the unit in general tab. If it is greater than 1 meter, also I need to get the unit of measurement as millimeter. If it is less than 1 meter also, it should be mm. So press OK. Again now go to result, take the drawings. Now you can see all dimensions are in millimeter. So you can also get the reinforcement detail here, the concrete quantity and the steel quantity. So with this video is over. Thank you. Look description for more related videos.